let P equal to, suppose this is the bent pipe. This is the pipe bend. This is the pressure, and this is the section 1, this is the section 2. P is the pressure intensity at section 1, and this is the area of pipe at section 1, and V1, P1 and A1, the velocity of flow. This is the pressure PA into A, and velocity and comma, and V1 velocity of flow at section 1, and P2 here, P2 in V2. Suppose this is the axis, this is the theta angle, and this is the pressure corresponding value, and P1 A1 pressure, and velocity V2. Now Fx equal to component of force exerted by flowing fluid on pipe bend in x direction, and minus Fx equal to, this is force, component of force exerted by pipe bend on flowing fluid in x direction. Similar, Fy is the same, and minus Fy same is in y direction. Understand? And consider this is the Fx and Fy. This is the force exerted by the fluid, and this is the Fx, force exerted by pipe bend, or exerted on fluid. Understand? Now momentum equation is in x direction. Momentum equation in x direction gives, we know momentum equation, net force acting on fluid, net force acting on fluid in x direction, and wipe this one. X direction equal to rate of change in momentum in x direction. Suppose this is the P1, this is the external force on fluid. This is the external force on fluid at section sec 1, section 1, and this is also external force on fluid. Suppose this side consider, and here velocity is v1 and here velocity is this direction v2, and positive x direction consider positive. No, this is the positive p1, this is the p1a1 minus this. Here this is the vertical and incline, the angle theta, so this is also theta. This is the pressure force, so this is the p2a2 into cos theta, and this is the p2a2 sin theta. Understand? Resolve in two component p2 and v2, this because this is inclined, and make theta angle with horizontal, so this is two component p2a2 cos theta, p2a2 sin theta. So this is the opposite, this is the exerted on fluid force, pressure force exerted on, this is negative sign, this is the negative x direction. And fx consider here, suppose take fx minus means this is the force exerted on fluid, fx. So momentum, rate of change of momentum, mass into velocity, this is the mass flow rate, m into velocity. Suppose here velocity as this inclined direction v2, so velocity, suppose this is the velocity, this is the theta, so this is component v cos theta into v sin theta. So momentum, and this direction, change in momentum, final velocity v2 cos theta minus initial v1. Only I consider the force, the direction. Now solve from here, we can easily solve fx, or you can write it rho a2 mass flow rate rho 2, you can write it, this is the a1 v1 into v2 cos theta minus v1. You can write it. Understand? And momentum equation is y direction. Momentum equation is y direction, and this is the p net force. Here the pressure force is 0, and here the pressure force is, this is the p2 v2 sine theta, and this is the downward is negative, p2 p2 a2, sorry, a2, this is v2 p2 a2 into sine theta, and fy, this is the force exerted on fluid minus sine. Just consider, and this value is when getting fx. This is the force exerted by fluid on pipe bend in x direction. This is that time, this is you can write, consider this is fx positive. Now momentum, change in momentum and velocity. Now this is the mass flow rate into velocity. Velocity, the final velocity is final velocity in y direction. This is the y direction. Y direction. This is the v2. Y direction, v2 cos theta, v2 sine theta, sorry, v2 sine theta, and initial velocity y direction is 0. Understand? And from this equation fy easily calculate, and fy is the force exerted by fluid on pipe bend in y direction. After getting fx and fy, now resultant force acting on fluid, resultant force acting on a fluid, acting on the net resulting force exerted, force exerted by fluid on pipe bend Fr equal to root over fx square plus fy square. Understand? And the direction or angle made by resultant force means Fr with horizontal direction, direction is given by tan theta fy by fx. Understand? And my next lecture discuss the moment of momentum equation.